Lesson 3, we are going to be determining roots of quadratic equations. So we're going to investigate this thing called the zero product law. So let's complete the following. For the first bullet, you guys with me? The first bullet, I get it. X minus 3 is 0 is true only if pretty simple idea, hey? Good. Because what you would do to the left, you would add 3 to the left and you would add 3 to the right and you would get x equals 3. So using that logic, like if it's minus 3 on the left, then you do the opposite of minus 3, which is plus 3. So for the second bullet, the opposite of plus 1 would be negative 1. Good. So negative 1 plus 1 would be 0. Now the next equation, which is a factored form, what happens when you multiply? How do you multiply two things? Because that's what factoring is. There's a little dot in between there. Bracket times a bracket. How do you multiply two things and get 0? Yeah. Yeah. One of them has to be 0 or both. Because 0 times 0 is also 0. So then this third bullet is going to be true if x is 3 or negative 1. And the next bullet, after that, all they're doing is adding or changing the a value. Change the a value from 1 to 2. Is that going to change this property? Because if you times 2 by 0, is it still 0? Yeah, so it's the same answers here. Now this last bullet is a little bit different. When is this going to be true? Well, I can do the negative 1 still. Okay, that one comes from this guy. But the next one. So why would it just be 0? Because there's no extra like plus something or extra minus something. It's like x plus 0. It's just 0. So if x was 0, this would be 2 times 0. What's 2 times 0? 0. And then 0 plus 1, that's 1. So 0 times 1 is 0. So if it's a binomial, you think of the opposite. If it's a monomial, it's just when its x is 0. Okay, let's keep going. So the zero product law. If the product, I'm just reading right here, if the product of multiple factors is equal to 0, then at least one of the factors must be equal to 0, at least one. So if a times b equals 0, then a equals 0 or b equals 0. So from that logic, we'll solve some factored quadratics equal to 0. This essentially means find x-intercepts. That's really what it means. So what happens when you have two factors? When you multiply, you get 0. That means one of the factors equals 0 or the other factor equals 0. And these ones are a little bit harder because the coefficient on the x is not 1. So these are a bit harder. So in the first worked out solution, what did they do with this plus 1? Send it to the other side as a negative 1 and then divide out the coefficient. That's a pattern that you guys have been familiar with for a long time. This is called a two-step equation. First, you isolate the variable with adding and subtracting, and then you isolate the variable with dividing and times it. So you get negative 1/2. What I want you to try, though, is to think about what it would be in your head. So I'm going to cover up that 2. See how that 2 is covered up? What would the answer be if that 2 wasn't there? What's the opposite of plus 1? And then how do you get rid of the 2? Divide it out. You want to try that again in your head? Cover up this 2 like it wasn't there. What would the answer be if it was just x plus 1? Negative 1. And then how do you get rid of the 2? Divide it out. So let's try this one in our heads. Cover up the 3 like it wasn't there. What's the opposite of minus 7? Plus 7. And then how do you get rid of the 3? You divide it out. 7/3. Okay, so let's show you that the long way. So plus 7, plus 7. And then how do you get rid of that 3? Divide it out. So what I want you guys to be able to do is get so good at these that you could actually just use your finger or something, cover up that coefficient. It's way easier if it's not there. What's the opposite of minus 7? That's plus 7. How do you get rid of the 3? Divide it out. So these are the two x-intercepts for this equation. Okay, let's keep going. Alright, so right here, this is what I just said. The roots is another word for the zeros, which is another word for the x-intercepts. So the stop note, it's a good little read, you know, pretty exciting stuff. So you have the equation x minus 2, x minus 4 in a product factored form is equal to 0. So the two solutions to this equation, because there's two solutions, what would make the left-hand side 0? If x was 2 or if x was 4. And you don't use the word and because x can't be simultaneously 2 and 4. You use the word or. Okay, so you use the word or, and then they're saying, okay, now you can actually say the word and. It's like an English lesson here. Right, so x is 2 or 4, but the x-intercepts are 2 and 4. I wouldn't worry about that at all. Okay, I would not worry about that. Okay, so when solving, they're using this word or. When you're communicating about the x-intercepts, they use the word and. That stuff's not going to make or break you. Okay, so let's talk about this first one. I'm going to do this the long way. A times B equals 0. So that means A equals 0 or B equals 0. A is x minus 7 and B is x plus 8. Isolating for x, you can see on this equation we have to add 7, add 7. And for this equation you see we have to minus 8, minus 8. Do you think I expect you to do all that? No. But that's why you understand. X minus 7, what's the opposite of minus 7? Plus 7. X plus 8, what's the opposite of plus 8? Negative 8. And that satisfies the equality, equal to 0. These two values are the x-intercepts. So these are called the roots, also called x-intercepts, also called zeros. So there's three different names for the exact same thing. And for some reason they interchange that vocabulary all the time. Yeah. Yes. Okay, also going to do this one the long way. A times B equals 0. So, what does that mean? A is 0 or B is 0. Let's just do B because it's a little. We've done B lots here. So what's x? B is the same as x plus 10. Throw the 10 onto the other side. X is negative 10, like we expected. But for the first one, A is 0, but what is A? A is just x, so x is 0. Oh, I don't have to do any work on that one. So that one, for some reason, catches students all the time, even though it's like the easier one. But in a way, it kind of catches you off guard because you get into this habit of like pattern spotting rather than like actually thinking about the math. You're just trying to look for patterns. Oh, plus 10, the opposite's minus 10. I know what I'm doing. But then x pops up and you're like, oh, there's no opposite of what's the answer? So that's this case here. X is 0. Okay, so and I'll just show you a check to prove that. If x was 0, you would have 0 multiplied by 0 plus 10. 0 times 10, 0. So there's nothing fancy there about the first case. But I show it extra because students will forget this one. This is a common mistake, this one. And I'll highlight it for you and write that down actually. So I'll put common mistake here because this one's screwed up lots. Okay, let's do the next one. So we'll do them the longhand. A times B equals 0, so A equals 0 or B equals 0. A is the binomial 2x minus 5. B is the binomial 3x plus 2. To solve these, you isolate and then divide. So you move the 5 over. Minus 5 on the left is a plus 5 on the right. Divide by 2. Positive 2 on the left will be a negative 2 on the right. And then you divide by 3. So those are the two x-intercepts, the roots. And then, especially if you go to 30-2, because this is actually like a preliminary skill before some harder things that you would have to accomplish. I would expect that 30-2 would be able to do this. Use your finger or something to cover up that 2, like that 2 wasn't there. What would be the answer if the 2 wasn't there? Positive 5. Well, how do you get rid of the 2? Divide it out. So what would be the answer if the 3 wasn't there? And then divide out the 3. And I'll just show you how simple this actually is. For that 3x plus 2, sub in the answer, which was negative 2/3. Look what happens. The 3's cancel and you get 0. Okay? So if I just got Here, let's do a random one on the whiteboard. And I just pick random numbers. And you should be able to do this no problem. 6x plus 7. And let's just put another one in there just for fun. Okay, so what I would do, and if you can't see the whiteboard, maybe just move for a sec. What if the 6 wasn't there? And then, yeah, good, divide out. And what if the 3 wasn't there? Yeah, this one's 4 over 3. Okay? Okay, so why are we doing this? That's the question you should always be asking yourself. Well, it's this. Solving quadratics. Solving quadratic equations. Okay, so if you had a question like this, what kind of equation is that? Why is it linear? Because the highest power on any x is 1. Now if you had something like this, is this linear? What's this one? Why is it quadratic? Because it has this power 2. For those two styles of equations, completely different solutions and methods. For the first linear equation, this is the stuff you've been doing since junior high. You're like, okay, get the numbers on one side and then isolate the variable. So I'd have to subtract 10, divide by 5, divide by 5. Okay? Quadratic equations, you cannot do that way. You can't put the x's on one side, the numbers on, it doesn't work that way. So in order to solve quadratic equations, and I'm just going to throw a negative on there, what you have to do is you have to get all the terms on one side, so move the minus 6 over to the other side as a plus 6, you have to make them equal to 0. And then you have to factor. And then you follow the zero product rule. These are the two answers to this quadratic equation. Completely different style of solving than linear equations. Okay? So why is there two answers? So that x squared plus 5x, that might look like something like this, right? And where does it equal 6? Well, 6 cuts across like that. There's 6. How many times does it intersect? That's why there's two answers. But for a linear equation, yeah, I can only ever touch once. For a linear equation, maybe this is the 5x plus 10. That's the 5x plus 10. Where does it meet 20? Only one spot. Okay, so two completely different styles. Okay, so that's why we need the zero product law. All that stuff we did in the first 15 minutes or so was a bit of a warm-up so that you can try to solve quadratics by hand without your calculator. And you can use all the styles of factoring that we've been learning over the past week. So we have inspection, difference of squares, and decomposition. And always check for the GCF if there is one. So you have GCF, inspection, difference of squares, and decomposition. You got to know those four. If you can't do all four of those well, then you'll have a difficulty with this exam, because this exam is like 80% factoring, this whole test. And it will only be those four styles. So this first question, this is an example of inspection. Inspection is just where you find the two magic numbers that work and plug them in. So which two numbers will multiply to a positive 20, add to a negative 9? Good, he's got it. So a negative 5 and a negative 4. So we can plug in x minus 5, x minus 4. So then they're saying, okay, now follow the zero product law. The zero product law states that each factor has to be equal to 0. So x minus 5 equals 0, or x minus 4 equals 0. And therefore, you use the opposite of minus 5, which is 5, and the opposite of minus 4, which is 4. Okay, so now I challenge you to plug 5 back into your equation. 5 squared is? Good. So if you plug them back in, you got 25 here, minus 9 times 5, and then plus 20. So 25 and 20 make 45. 45 take away 45, you get the 0. And the same thing will happen if you plug in a 4. If you plug in a 4, you get 16 minus, what, 36 plus 20. So 16 and 20 make 36. 36 take away 36, you get 0. So if you look at the two equations, and I'll highlight them, they mean the same thing, but one is way easier to solve than the other. X squared minus 9x plus 20 equals 0. It's very hard for me to decide for a sum or a difference equal to 0. It's very difficult for me to even conceptualize that. But a product equal to 0, well, that's easy. Why is that easy? Because when you times to get 0, one of the factors or both have to be 0. So this gives rise to, why are we factoring in the first place? The reason we factor is so that when you have a multiplication equal to 0, it's superbly easy, because you're just timesing. When you times to get 0, one or both are 0. Okay, now we can actually do this. First, and I will let you guys try this, the factoring at least. So for question A, go ahead and try and factor. Alright, so there's the factoring. Now what's the two solutions? Because you actually have to solve it now. So x is 7, or x is negative 2. So the factors are minus 7 and positive 2, but the actual solutions are the reverse of that. Because remember, you have some quadratic equal to 0. What value of x will make the left side 0? Well, a plus 7, because then you have 0 times 9. No, because it ends up as a minus 5. So you need a minus 7 and a plus 2. For part B, what's jumping out at you with part B here? Please don't just yell at the answer. What, perfect what? Yeah, 4 and 25 should really be jumping out at you. What's the other thing that's like missing from this? The middle term, good, the one that just has x, right? So there's no middle term. If there's no middle term, look for perfect squares. So how is this going to factor? 2x minus 5 and 2x plus 5. And that's equal to 0. So this is where I would do that thing where you use your finger to cover it up. Cover up that 2 like it's not there. What would the answer be? What if that 2 wasn't there? What would the answer be? 5, right? How do you get rid of that 2 though? Yeah, so there's one of the answers. And the next one's the exact same, except it's a negative. Yeah, so then this is what they'd have for like a, it's just more beautiful, this version. Just looks nicer, but it's the same thing. So when you have difference of squares, you'll always have plus and minus. Let's do another difference of squares just off to the side here. X squared minus 9 equals 0. How would that one factor? X plus 3 and x minus 3. So the two answers are negative 3 or 3, which you can write as plus and minus 3 like this. Okay, so that was just an extra question there. Now the next two are similar, but a little bit different. So let's do the first one. What's up with this? There's no constant. Good, there's no C value. So can we do the inspection or decomposition if there's no C value? No. And 10 and 90 are not squares. So the only thing that you have a chance at is GCF. So what do they have in common? You can divide out 10, and do they share any x's? How many x's do they share? A single x. So you can factor out 10x. That comes out to the left, and then you're left with what on the inside? Beautiful. And that is equal to 0. So the one on the right is easy. That's 9, right? But what about when x is just by itself? Ah, good. It's just 0. So I would try to memorize that one. If x is just by itself, 0. Okay, let me switch colors for the second one here. So we got 10x squared minus 90. This one's a little bit different because there's no x on the second term. So what's the only factor you can take out? 10. So 10 comes out, and what are you left with? Oh, what the heck? Didn't we just do that? That was lucky. We just did that one, right? That was just pure chance, by the way. I didn't know that was coming. I swear. So then you can keep factoring that. You get x plus 3 and x minus 3. So what are the solutions? This one gives you x 3. This one gives you x negative 3. And what does this one give you? Yeah, there's no x there. Yeah, you don't do anything with that one because 10 is always 10. 10 will never change. It's different than this one because what's this? That's 10x. That one can change because x changes. So 10x can change. But 10 never changes. 10 knows who he is. Yeah, yeah. He's very self-aware. So these are the only two solutions. So your final answer for that one would be x equals plus or minus 3. Sure. We got one more question if you want to wait. Okay. All right. All right. So class example 5 is where they're trying to mess with you. Class example 5, they legit are just trying to mess with you. Because you have to do you can't just jump in here. You can't say like, oh, x is 0, x is 4, because what does it equal? Not it equals 5, not 0. So what you have to do, and I'll jot this down on the side, expand or factor or basically algebra. Do algebra until until you have f of x equal to 0. That's what you need. You need some function equal to 0. So you might have to do algebra, you might have to expand factor, you might have to do some magic. So for the first one, you have to expand in here. So you get x squared minus 4x equals 5. But I don't want it to equal 5. What do I want it to equal? 0. So what do I got to do with that 5? Subtract 5 to the other side. And then now you can go ahead and factor this. So this one's inspection. Do you agree? What makes this inspection? What's in front of the x squared? A 1. That makes it very easy because it's 1x times 1x. Now how are you going to make minus 5 with a product? Negative 5 and plus 1. So the two answers are x equals 5 or x equals minus 1. All right, now the next one. So for the next one, do you have to do any expanding or anything? No, there's no brackets or anything. So you just have to move terms left and right. So do you want to put everything on the right or everything on the left? Why would you put it on the right? So last week I mentioned a few times, I hate when the lead coefficient is negative. So if the lead coefficient, which is the coefficient on the power 2 term, if it's negative on the left, put everything on the right. So then you have 3x squared over here. Now, is this inspection? Is this inspection? No, because there's a 3 here. If it's a 1, you're good. If it's a 3, you got hard work to do. We can't do any GCF because 13 is prime. Decomposition. I think I spelled that right. This O, I think that's an I right there. Decomposition. It matters. I got it right? Okay. Well, sometimes when you write it and you look at it. Okay. Sometimes you look at it and it looks funny. Okay, so now we still have to do that thing where we have to find the magic numbers. You guys remember this from last week? Okay, I need two special numbers that multiply to -30 and add to -13. It's not 3 and 10. Not 3 and 10. Because it would have to be -3, -10, but those multiply to +30. Gorgeous. So 15 and 2, which one's negative? Okay, so we're going to change this to -15x plus 2x. Because this was 15 and 2. So this is sort of off to the side. It's like a brainstorm step. You keep the front, remember that? And you keep the back. Then you put them in pairs. GCF for the pairs. The first GCF is a 3x. You're left with x minus 5. The second pair you can take out a +2 and you're left with x minus 5. So x minus 5 is one of the factors. The other factor is 3x plus 2. So the two answers are, from the first term, x equals 5. And then this one, cover up the 3. What if the 3 wasn't there? -2. How do you get rid of the 3? Divide it. Alright, so basically you're staring at your written response here. Like this is a fair written response. Make sure the function's equal to 0, factor, and solve. Like for sure that'll be on your written response. I can't guarantee how it'll start originally, but essentially you'll have to be able to do this, especially with the decomp. The beautiful thing, folks, is when you get to 30-2, they don't expect you to do decomp anymore. They keep it, yeah, it's nice actually. They keep it to inspection and difference of squares and GCF. So you don't have to do any of the decomp. Yeah, it does. It does. Because they teach you so much more extra stuff that it's like, and you've already been taught it in 10 and 11, they're like, okay, enough is enough. Alright, so for the homework, like questions 1 and 2, you should be able to whip through those in like less than 5 minutes. But question 3, I'll just jot this down for you. Question 3 is inspection. Actually, 3 and 4 are inspection. Question 5, what do you think for question 5? Looks like some mostly difference of squares. You see it? Except for the first one. The first one's GCF. But all the other ones are difference of squares. And then, yeah, make sure you get to 7. So lots of time left in class, about 50 minutes. So please, 1, 2, 5, and 7 are an absolute must. Yeah, I would say 1, 2, 5, 7, and 9. Absolute must.